Hello students, and welcome to this lesson on the inverse of a quadratic function. Our objective today is that we will graph and write the inverse of a function with f to the negative 1 of x notation using journal notes and practice. So just a reminder that f negative 1 of x is the inverse of f of x. So it's the thing which undoes everything which f of x does. So I know that we've already worked a lot with inverses, so we just want to define them a little bit more strictly and kind of ease back into them. So one thing that we're going to define is what it means to be one-to-one when you're in a function. And that definition is that to be one-to-one, a function is one-to-one if any two different inputs in the domain correspond to different outputs. So given that x1 and x2 are different, then f of x1, or the function of x1, is not equal to the function of x2. So this is something that we have commonly used to determine whether or not something is an inverse. You remember the horizontal line test, and we're going to go through that again today. So let's just run through a couple of examples of different functions and see whether or not they are one-to-one. All right, so looking at example 1, we're going to find the inverse. So first, let's see if this is a one-to-one function. So check, we just have to draw little arrows and make sure to ourselves, all right, so 1 goes to 0, 2 goes to 1, 3 goes to 2, and 4 goes to 3. All right, so is there any repetition there? No. So this is a one-to-one function. For every input, there is exactly one output. And that output is different from all the others. So if I was looking for the inverse of this, remember the inverse is just where we flip all the values. So I go 0, 1, 2, and 3 become my x values, and my inverse values are going to be 1, 2, 3, and 4. So pretty simple, taking an inverse of a table. All right, let's look at this next one. So this is a list, right, of coordinate pairs. So this is the same thing as what we just did, except it looks a little different. So I have the point 2, 1, the point negative 3, 1, and the point 7, 6. All right, so let's see if this is indeed a one-to-one function. So 2 goes to 1, negative 3 goes to 1, 7 goes to 6. So is there some repetition in there? Yes, so 2 goes to 1, and negative 3 also goes to 1. Therefore, this is not 1, 2, 1. So that'll cause us some problems later, but we'll get to that. All right, so if I was going to find the inverse of this, all I need to do is interchange the x and y values of the points. So every x becomes a y and every y becomes an x. So this becomes the points 1, 2, the points 1, negative 3, and the point 7, 6. So that would be the inverse of that original function. All right, let's talk about the horizontal line test. You guys are familiar with this. The horizontal line test is the theorem, right? It's a theorem. If every horizontal line intersects a graph at exactly one point, then the function is 1, 2, 1. So again, we're talking about that one-to-one condition. And one-to-one is very important for when we start to determine whether or not two things are inverses or not. So we have our function here, and we have two different functions. I have the function x squared, or some variant thereof, and I have the function x cubed, or some variant thereof. So if I do the horizontal line test on x squared, what do we notice? Well, we know that in several places we see that the graph is getting crossed in more than one place. So our horizontal line test for our quadratic functions, the quadratic function as is will actually fail. So this fails horizontal line test. However, if we look at x cubed, it looks like x cubed without any restrictions will pass. The only trouble spot might be in here, but actually what we find is that this point here is an inflection point, and there's actually no overlap in an x cubed function. So what we've learned here is that this will pass horizontal line test. Which means that this function can be called 1, 2, 1. All right, so really what we're interested in, sets are kind of cool, but what we're really interested in is finding the inverse of equations, right? That's something that we've done all the time, or that we have done in the past and that we will continue to do in the future. So let's just review how we're going to look for the inverse. First, I want to perform the horizontal line test to determine if it's 1-to-1. If it's not 1-to-1, I can't find an inverse for it. So perform horizontal line test. All right, and then so if it passes the horizontal line test, then I can move on to this next step. And the next step is going to be solve for x equals. So that means to get x by itself, and you guys have done this before. It's effectively you're treating y as x and x as y. That's the situation that we're talking about here. Then we want to change notation. Change x to f-1 of x and change f of x or y to x. So f of x or y is going to become our input, our x value, and our x value is going to become f-1 of x. All right, and then our final step here is that we're going to restrict domain if necessary. All right, so now, using this process, we're going to solve for some inverses. So let's use this first function, right? So I'm just going to draw a little sketch over here to the side. First, I have to perform my horizontal line test to see whether or not the inverse is actually, existing. So I've got my line, and it kind of looks like this. And a straight line is always going to pass the horizontal line test, so I don't actually have to worry too much. All right, so that's awesome. So now I can move on. So first, I need to solve for x equals, so I need to get x by itself. So the first step to doing that is going to be that I will subtract 2 from both sides. So I get f of x minus 2 is equal to 5x. And then I get both sides dividing by 5. And so I get f. So I get f of x minus 2 divided by 5 is equal to x. And then I do my notation change. So this is going to become f-1 of x is equal to, now f of x becomes x, so x minus 2 over 5, and I am done. So that's how I find that inverse there. All right, then I've got my other question here, and again, I'm going to perform a quick and dirty little horizontal line test. So I draw my function here, and it looks like it's probably going to be about, we're just going to say it's right there, right? But again, I notice that it will pass the horizontal line test. No matter which horizontal line I put, it's going to pass it. So that's going to produce an inverse. So let's go ahead and go through our process again. Now, instead, I've got this out here first. So to get rid of the square, sorry about that. To get rid of the square root, I'm going to have to square both sides. So I square this side, so now I have f of x squared is equal to x plus 5. And then I see that f of x squared, I need to subtract 5 from both sides. So f of x squared minus 5 is equal to x. I do my notation change, and what I get is that f negative 1 of x is equal to x squared minus 5. All right, so real quick, let's talk about the inverse of a quadratic equation. So as we saw earlier, the quadratic equation will actually fail this horizontal line test. So in the standard form, no inverse exists. But I can do something to create an inverse. So if I look at this equation, this equation reflects across this line in the middle here. So let's say that I restrict my equation so that I only have the positive outputs. So I'm going to say that x is greater than or equal to 0, and so I've only got this one arm here, right? So when I take the inverse of this, I see that it will pass the horizontal line test. So on a restricted domain, I'm able to get an inverse for the quadratic equation. So then, if I said that this is going to be, let's just say that it was something like f of x is equal to x squared plus 2, right? So then, if I'm restricting it on this domain like this, then I can actually find an inverse in the normal way. So I can say f of x minus 2 is equal to x squared, and I'm going to find that the inverse, f of x negative 1, is equal to the square root of x minus 2. So that's going to be our inverse, and we see that that's a square root function. And that's kind of what we were getting at today, is that this is actually going to be our square root function as the inverse of our quadratic function. All right, so before you get started on your practice, which is 1-4, what I want you to do is write a summary of what you learned. So you can use some sentence stems. So maybe something like, what I learned today, or I can connect to this, and there are several more sentence stems, and they are posted around the room. When you're done with your summary, make sure that I come around and check it off. I'll come by and stamp it. And additionally, make sure that you get started on practice 1-4 for your homework. That's also your in-class assignment, so make sure that you're working on that diligently today. All right, if you have any questions, go ahead and ask me, and have a wonderful day.